So for my final project, I decided to do it on Google Self-Driving Vehicle. And the reason I decided to do it on this is because I wanted to focus on something that a lot of people really don't know about. And I also wanted to learn more about the technology it uses and how the vehicle actually drives itself. One of the biggest questions people ask is, why did Google all of a sudden want to be involved in making cars? Well, the reason for that is because they wanted to use technology to make people's lives easier and better. And they believe with self-driving technology that they could use that technology in order to make driving a lot more enjoyable, a lot more safer, and change people's lives. When Google first started using self-driving technology, they didn't really have a vehicle to use it on. So what they did was they got a fleet of Toyota Priuses and a fleet of Lexus RS450 hybrids. And what they did was they incorporated all that self-driving technology into these cars by modifying them, and they were able to make them fully functional self-driving vehicles. Now, these type of vehicles, they were still required to have a passenger in the front seat, in the driver's seat, in case something went wrong with the car. And at the time, they were being tested in areas around California and in Nevada. And the total amount of miles that they logged in was over 700,000 miles. And they were also being tested on public roads, like highways and traffic, and roads with human intervention, which was pedestrians, people on bikes, and even road workers also. The equipment that these vehicles use is very costly. It could cost up to around $150,000 on each vehicle. And some of the equipment that these vehicles use, they use a LiDAR, they use cameras, radars, sonar, GPS satellites, and they also use a special software. One of the most important pieces of equipment that these vehicles use is a LiDAR. And what a LiDAR is, it's a laser illuminating detection and ranging system, and it is used to build a 3D map that allows the car to see objects or any potential hazards. Now, the LiDAR itself uses a Velodyne 64 beam laser, which can take up to 1.3 million readings per second. And what the laser does, it bounces off all the surfaces that are surrounding the car, and they can determine the distance of how far an object is. And the LiDAR, it has a range of up to 100 meters, and it's also mounted on the roof. And the reason for that is because of its accuracy, and also it ensures that the view is not obstructed by anything else. They also use cameras that are mounted in pairs around the exterior of the vehicles, and the reason for that is because they allow the system to track an object's distance in real time, and they also provide an overlapping view of the vehicle's surroundings. Now, these cameras also provide a 50-degree field of view, but they are only accurate to about a 30-degree field of view. They also use radars, and the reason for that is because the LiDAR system that is used, it doesn't have the ability to detect the speed of other vehicles in real time. So what the radars do is they actually monitor the speed of other vehicles in real time. And Google incorporated 4 different radars, 3 of them which are mounted in the front bumper, and one of them is mounted out in the rear bumper. And they're used to avoid impact, and they're also used for the long range of view. They also use a sonar system, which is used alongside with the radar system. And the sonar, it's used for its narrow range of view, which is about 6 meters, whereas the radar system, it's used for the longer range of view. And what this does is, if a vehicle or anything crosses in front of the radars or the sonar, it sends a signal to the processor, which it then knows when to apply the brakes, swerve out of the way, or even tighten the seatbelts if needed to prevent a possible collision. One of the things that is very important in these types of vehicles is knowing exactly where the vehicle is supposed to go and determining its exact location. What Google did was they used GPS satellites and software to determine that. They used a wheel encoder to determine the vehicle's actual speed, which is mounted on one of the wheels. They use the software, which they take all of the data from the sensing systems and they use it to build a map of the vehicle's position. Now, these maps that they use are very detailed in that they have the exact dimensions of the lanes it's traveling on, and even has the curb size as well. Everything is also processed in real time. One of the things Google also wanted to do was they also wanted to make their own vehicle. They had a prototype design, which they unveiled back in May 2014, and they actually announced it in December 2014, which is that picture in the slide of what the vehicle actually looks like. This vehicle was created from scratch by Google. It has no pedals or steering wheel. It's a fully electric vehicle, and it can carry up to 2 passengers. The vehicle does have start and stop buttons for the passengers that are on board in case an emergency were to happen. Now, the company that is actually building this vehicle is Roush Industries, and it's actually being built in Livonia, Michigan. And some of the suppliers that are going to be involved in this project are Bosch, Continental Automotive Group, RCO Engineering, Fremo, ZF Link System, and LG. Bosch is going to be providing the electric motor. It's actually called the E-Machine. And they're also going to be providing the LiDAR, which is probably going to be the most expensive piece of equipment on the vehicle, which is going to be around $70,000. Continental Automotive Group, they're going to be providing the brakes, interior electronics, and also body controllers. RCO Engineering, they're going to be providing the seats. Fremo is going to be providing plastic components for the interior and the exterior of the vehicle. And ZF Link System is going to be providing the steering gear. And the company LG, they're going to be providing the battery. Some of the obstacles that Google still faces with the self-driving vehicle is that if they were to ever go into production with it, they would need to constantly update their maps since they use the GPS satellites. And another thing also is that they still haven't tested it yet in certain conditions, including snow conditions or stormy conditions. So there's still the issue of how would the car react in those certain types of conditions. Another big problem is the regulations. As far as regulations goes, since the vehicle is being tested in California, the California's DMV, the number one concern is that they don't know if the vehicles are safe and they don't know how to regulate it. The only reason Google has been testing in roads in California is because the California DMV, they issued them a permit along with a few other companies, and that's the only reason they're able to test their vehicles on public roads. And currently to date, there are also no federal standards on these type of vehicles. Some of the advantages that these type of vehicles have is, one, they eliminate the risk of human error, and another being that they are safer than a conventional vehicle because they use radars and sensors to detect objects and vehicles around them. They also have the ability to detect pedestrians as well. And another advantage would be disabilities. They would no longer be a factor. And probably the number one advantage would be the reduction in the number of deaths that are related to vehicles. Some of the disadvantages is there still is a high possibility that there could be a malfunction in the electronic system. Price is still a major factor in this, that the equipment the vehicles use is very expensive, and also it's going to have an impact on the economy as well as impact on automobile manufacturers if these types of vehicles were to ever go into production. And that concludes my presentation. Thank you.